Well, hello, my little triglets. We are going to start Chapter 5, Section 5.1. This chapter is all about right triangles, so it should be somewhat familiar to you. Remember, we have the fastest way to do right triangles when you're missing some information. SOHCAHTOA, where sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now let's review real quick what that means. If I have angle A here and I have side A, side B, and side C. If you're looking at angle A, the side opposite is side A. And the side adjacent to it is side B, and side C is always the hypotenuse. So if you're looking at the sine of angle A, you want opposite over hypotenuse. So that would be A over C. Now if I switch it and go to side or angle B, then the sine of angle B is opposite, which now becomes B, and hypotenuse is still C. So it all depends on which angle you're coming from as to how those work. So if you see the word solve in the directions, that means to find all missing sides and angles. All right, so let's try a problem here. So here's my triangle, and I have A, B, C. This is A, this is little c, and this is little b. And all we know is this is 37 degrees. So if I want to solve it, I need to find side B, it was already 18, angle A is 37, and angle C is 90. So I need to find angle B, side A, and side C in order to solve it. So let's try to find little c to start with. So I am looking at angle A, and I have 18, and I want C. That just turned to black for no apparent reason, but we'll keep going. So adjacent and hypotenuse. So I'm looking at cosine of 37 is adjacent over hypotenuse. Now because C is on the bottom, we have to switch these two. So C is 18 over cosine of 37. You work that out and you get little c to be about 22.5. So we'll put that in. All right, now we need to find little a. Now we have that this is 22.5, but that's rounded. You don't want to use a rounded number with a given number to find another side because it will be off because of the rounding. So do not use anything unless it's given. So the 37 and 18 should be the only things you're using. So I'm going to try to find little a. So little a becomes the tangent of 37 because I have opposite and adjacent. So I have a over 18. Now you can cross multiply 18 times 30 tangent of 37, and I get approximately a to be 13.6. Now again, that's rounded, but if we're rounding nearest tenth, that's good. Now angle B is easy. We just have to figure out, take 90 and 37 away from 180, and or you can just do 90 minus 37, which is 53. So 53 degrees, and we've got the whole problem solved. All right, let's do a different kind of problem, but using the same information, the SOHCAHTOA stuff. I've got K, L, M. This is 19.8. This is 19.8. And this is 38. And I know it's an isosceles triangle. And if I draw in an altitude, the altitude is the length ln. I want to find km. And we'll do it to the nearest tenth. Okay, so we've got an altitude here. An altitude says that it's a 90-degree angle down there at the bottom. And now if I want to find, let's say I want to find this side from K to N, I'll call that X. I've got the angle 38, I've got adjacent, and I've got hypotenuse. So I can say cosine of 38 is X over 19.8. Then you cross multiply again, you get 15.6 rounded, but that's just half of what we need. I need to find km, so I'm going to multiply it by 2 and round it, and I get 31.2. Okay, so that's just a different variation of the same information. You have to use some of your geometry knowledge to be able to realize that altitude makes a 90 degree. All right, let's look at some other things here. Angle of depression is something you're going to need to know. And if I have a horizontal line, the angle of depression is the one down from the horizontal. Depression is down from the horizontal. If you have angle of elevation is up from the horizontal. Okay, up is elevation. Okay, so, but you always have to remember it's from the horizontal line. Okay, otherwise that can get a little bit tricky. All right, let's say you have a security light and it's set to go off when it senses movement 40 feet away. Okay, I want to find the angle of depression. If the light is 8 feet up the wall. Okay, so here's our wall. That's 8 feet. We have the light is right here, and it senses 40 feet away. So this line down here is 40 feet. I want to know the angle of depression. Now this is where you got to be careful. It is not this angle here, okay, because that doesn't have a horizontal line attached to it. If I draw in the horizontal line, the angle of depression is here. All right, so that's different. Now, these two lines are parallel, and you know from geometry that alternate interior angles are equal, so this angle of depression is the same as this angle in here. So what we really want to do is find angle A down here at the bottom. So I have opposite and adjacent. That means the tangent of angle A is 8 over 40. So figure out what 8 over 40 is, which is 0.2. And then you have to do the inverse because this is like the alien. Angle A is like the alien. So we do inverse tangent of 0.2, and I get approximately 11 degrees. So this angle of depression is 11 degrees. Okay, so you have to be very careful that you're going from the horizontal. All right, so the last problem I want to show you is a problem about Mother Earth. We'll do it in blue. Here's the radius, or I'm sorry, the circumference. And if I show that going all the way around, I want to set up a formula or to find a formula to find any, there it goes turning black again, any parallel around the Earth. Okay, so each of these lines is considered a parallel. So this one here is the equator. It's right in the middle of the Earth. A few things we have to know is that the radius of the Earth from the center is 6,400 kilometers. Okay. You also know circumference is 2 pi r. That's the distance around. Now let's look at what we have here. If I have the radius going across, and let's say I draw an angle here, we'll call it angle B. This is also the radius. Now keep in mind that if I make a triangle here, I've got a right triangle, I can make another angle here. Now just bear with me a second here. Here's another altitude line. I'm going to call this little r because it's not all the way across the entire circle. Like this is, whoa, this radius down here, come on, is from the very center of the Earth. This one is not. It makes a smaller circle up here. So it's a different one. So if I want to find any parallel, I have to find one that's not on the center. Now look at the triangle that I'm making right here. All right, this angle B is also this angle here because they're alternate interior angles. So let me draw the picture of this other triangle, this red one over here. So this is angle B, this is little r, and this is big R. So is it accurate to say that the cosine of angle B is adjacent over hypotenuse? R, little r over big R. All right, so now let's go back down here. Here I have little r. So the circumference at any parallel is equal to 2 pi r. Now our little r became, if I cross multiply over here, I get r cosine b equals little r. So I'm going to put in for little r, r cosine b. So that's how the formula was derived. It was just by making triangles all over the place and finding one that fits our issue of finding any parallel. So from here on out, this is the formula you're going to use. Let's say I want to find the length of the 43rd parallel. So I take 2 pi. Now r, we just said the radius of the Earth is 6,400, so we put that in. And then cosine of b, b is our 43rd, because this number 43 stands for how many degrees up from the equator it is. So our distance around, or our circumference, is equal to all of that. So if I multiply all of that out, I get 29,409 kilometers. Okay, but the main thing is to know this formula and to know that the Earth has a full radius of 6,400 kilometers. Okay, that is it for today. Don't ever forget, if you love Trig, it will love you. Ta-ta for now.